Hi, welcome to Lambton College ICS 340 online labs. I'm Kevin Ryan and I'll be your instructor today. Now today we're going to be working on the IDP, which is also known as a transducer. We're going to have to plumb up our transducer. Now first, we're going to plumb up our supply air to the 20 psi port, and we're going to hook up the output from our transducer to a pressure indicator. Now during today's laboratory experiment, we're going to be sourcing a milliamp current to our transducer through our Fluke 744 process calibrator to our transducer. Now that transducer converts that current into a pressure. An ideal place where a transducer or an IDP such as this would be used would be on or near a valve to open at 3 to 15 psi or 20 to 100 kilopascals. Now for our experiment today, we're going to be reading our measurement in kilopascals. Now that we are wired up, I'm going to connect our pressure to our transmitter. Now we're going to start out by placing 4 milliamps through these wires to our transducer. We're looking for a 20 kilopascal output. Now currently we're reading about 21.62 kilopascals, so we're going to start with adjusting our zero screw. Now on a transducer or a transmitter, they usually have a zero and a span screw. Our zero being 4 milliamps, 20 kilopascals, or our 20 milliamps being 100 kilopascals. So if I make a slight adjustment with our zero screw and slowly decrease the output pressure. Very, very important to be as close or as accurate as possible. There we are, 4 milliamps, 20.02 kilopascals. Now it's okay to be plus or minus 0.05 kilopascals for our output scale. Next we're going to go to our 20 milliamp output to try and render a 100 kilopascal output. Now 20 milliamps is placed through this transducer onto a coil. And inside that coil, more current that is induced onto that coil, there's a magnet that is either attracted or detracted through that transducer. When it's attracted more by applying more current, the output through a flap or nozzle arrangement can allow more pressure, and on the detract state or less current, it'll be less pressure output. So I'm just going to adjust our span here for 100 kilopascals. Now usually through a transmitter or transducer calibration, we like to do this step at least twice to verify that the calibration had taken place and is stuck into the transmitter. Now I'm going to take and place 4 milliamps back on the transducer to check out our calibration. Once again, adjusting our zero and then go into our 20 milliamps again. Now that we've completed our calibration, let's go through upscale and downscale in 10% increments. Now, at 4 milliamps, note that our output pressure is about 19.84 kilopascals. Next, for our 10% increment, we will be going to 5.6 milliamps. At 5.6 milliamps, we are at 27.6 kilopascals. Next, we will do 7.2. Milliamps, we are rendering 35.31 kilopascals. Next, let's go up to 8.8. At 8.8 milliamps, we are at 43.57 kilopascals. Next, we'll go up to 10.4. At 10.4, we are reading 51.73 kilopascals. Next, for a halfway point at 12 milliamps, we should be rendering around 60 kilopascals. And currently, we are at 59.95 kilopascals. At 13.6 will be our next step.